Okay, another example on partial variation. We have here x varies partly as y and partly as z, right? So we're told x is equal to 40 when y is equal to 4 and z, and z is equal to 3, and then x is equal to 5 when y is equal to 2 and z is equal to 1. So let me just make it clear, that's a z there. Okay, so find the relationship between x, y, and z. Then part B, find x when y is equal to 2 and z is equal to 1. And z is equal to 1. So solution, right, is to first of all come up with my two equations. Now here we know that x varies as y and as z. So now the first part, it varies as y, and the second part, it varies as z. And now I'm going to put two constants, a constant for each part, right? X varies as y, and x varies directly as z. So you have the constant for each part there. And then I can substitute the values that I had there. Remember, I had 40, 4, and 3 for my x, y, z values. So I can substitute there and put 40 is equal to 4k plus 3h. That's my equation 1. And then I have 5, 2, 1, right? You can substitute those. 5 is equal to 2k plus 1h, which is just an h. Then I get my two equations. So to solve these ones here, what I'm going to do is I want to eliminate k. I have a 4 there and I have a 2 there. So I want a 4 there as well. So I'll multiply the equation 2 by 2, right? My resulting equations, the first one will still be 40 is equal to 4. Let me just put a line to separate there, right? I have 40 is equal to 4k plus 3h. That's still my equation 1. Multiply the whole second equation by 2. So 2 times 5, that's 10. 2 times 2, that's 4. And 2 times h, that's 2. So that's my equation 2. So now I can subtract this second equation from the first one. 40 minus 10, that's 30. 4k minus 4k, that's 0. So that's eliminated. Then 3h minus 2h, that's simply an h. So my value for h here is 30. So I now know my value for h. I can substitute in the first equation, right? Remove that. So first equation is what? 40 is equal to 4k plus 3h, right? We can substitute for h, which is actually 30, right? So 40 will be equal to 4k plus 3 times 30. So 40 is equal to 4k plus 3 times 30, that's 90. Take 90 that side. 40 minus 90 is equal to 4k minus 50 is equal to 4k. All right. Let me make sure that's a clear 4k. Divide both sides by 4. I get minus 12.5 is equal to k. So now I know my h and my k, so I can go back to my original equation. My original equation was x is equal to ky plus hz. But my k was minus 12.5 and my h was 30. So x is equal to minus 12.5y plus 30z. That becomes my relationship. So that becomes my relationship. Now for the next part, we know we need to use our relationship, which is x is equal to minus 12, 5 y plus 30z. So we're told, if we go back to our question, find x when y is 2 and z is 1. So y is 2 and z is 1. So x will be equal to minus 12, 5 times 2 plus 30 times 1. X will be equal to minus 12, 5 times 2. Oh, sorry, why am I repeating that? That's minus 25 plus 30. X is equal to 5. Actually used values that I had used to get here in the first place, but that proves the truth of this relationship here. So you can look at it and you can answer questions on partial variation. That should conclude the topic on variation.